Okay, so we will find as a data warehouse too. So if we start, if we look at like how many tools and components we are going to use. Okay, so if we so we started from the Hadoop fundamentals, right? Big data fundamentals, data fundamental concept, right? So basics, right? Where the big data being used, right? And then Hadoop fundamentals. Hadoop fundamental comes with the Hadoop architecture, right? SDFS, Hadoop architecture, MapReduce architecture, and SDFS architecture. So all this comes in the Hadoop architecture, SDFS and MapReduce architecture. And then we see this is a theoretical part. After that, we see that the Hadoop command, developer command. So these commands we use for transferring the data over right, to the Hadoop file system from our local file system. And the next thing we started MapReduce. MapReduce is the computing part of the Hadoop basically. And there we have seen yesterday map and reduce functions. So they are the two functions are there, map and reduce function. So map is splitting the data and reduce is basically aggregating data. But between the map and reduce, there is one more step is there map and then shuffle and sort. Shuffle and sort is basically shuffling the keys, the same key together, and then after it is doing sorting, and then the reduce phase comes in. Okay, one shuffle and sort and reduce phase. So we have seen yesterday, right, how to write a MapReduce program. The MapReduce program having a three component, right? We write a driver class, driver Java class, that is the main class. The main function is there, the entry point, and we have mapper class, and we have the okay. So mapper class have the map function, and reducer class has the reduce function. So we think that we have to we this MapReduce program is shipped to the all the data nodes where the data is, and it is doing the computation. And we seen that there is a partitioner is there in the MapReduce that is for readability purpose, like multiple output files to generate multiple output files are generated, and these multiple files are output generated, and then we can find our output result. And there is another component in the MapReduce is a combiner. The combiner is a component which is improving performance of MapReduce program, because sometimes we have like multiple, like the keys are repeated. Keys are repeated on the same mapper. Keys are repeated on same mapper. Then 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 the reducer class. Then reducer class is used as a combiner at mapper side. Mapper side to aggregate the keys, aggregate the keys, aggregate the keys, and get key value pair. Okay, and and the reducer is used only for when the multiple mapper machines keys should be aggregated. So that's a big difference between the reducer and combiner. Okay. Now the next is like we are going to do today is the map joining. So we come like MapReduce has the join also. MapReduce joins are there. So there are the two types of join. So one join is a map side join, and another side is a reduce side join. Second join is the reduce side join. So when we say joining is happening at the mapper side, that is called map side, and reduce side join is the joining is happening at the reducer side. So if one example, yesterday I was showing the example to you guys, right? Like I have a employee.txt file and one is a department.txt file. I want to combine the data of this employee and department, because there is a department ID is a common. I say employee ID is there, employee name is there, and an employee department ID is there. And same like a department has the department ID and department name. And I have another department 102. This department is suppose payroll department. Now I want to get the result like this, one test, and I say, I want to print the department name. I'm not interested about the department ID. So I can say, I have, this is a different employee. One employee can have multiple departments also. That could be one case. So we have these are the employee IDs, employee name, and department name. So this kind of joining is a map site join. So there is no reducer required. So joining is happening at the mapper site. That is the reason it is called map site. Okay. So I will show you the code, right? How to use map site join. And the second join is a reduce site join. So one example I will take for the reduce site join, like I say, I have a customer and orders. Okay, so I will say some customer is there, like customer ID 1, customer ID 2, customer ID. So customer ID has the customer name. Okay, suppose I say customer XYZ and he has the order 101. Okay, and I say another customer is customer ID, customer name, and he has the order 102. And this order having like one customer can have multiple order, right? So I want to do the total cost of the order. I say when customer has one order ID 102. So I want to find the aggregation of all the order of same customer, right? So order table has different orders and their cost is there. 01 has some cost is there in return. Another customer order is having 102, but having an order cost. So so basically I have to do aggregation thing. Okay. So I want to get the total order for the customer ID 1 and total cost of the order of the customer ID and how many order of this customer. So this kind of things I need a two mappers. So one mapper who will be reading the data for the customer, who will be reading the data for order, another mapper. And then we have a one reducer, which is combining the data of order and customer aggregation scheme. Okay. So that example is basically the reduce site join. So this is a map site join example. This is the map site join. This is the map site, and this is the so is it understood?
Yes, Arvind. Yeah.
So yeah, how to do this? So I have already shared the one matrix project. If you are able to access or not, you know, and in the classroom, it is not providing the download option. So I will share the separate Google Drive with the separate folder. So whatever source code will be there, I will put it in the drive, and that drive access I will give to everyone. So you can download the code, right? Because if you are trying to download code from the classroom, so it is not downloadable. So I will do that. So we need a IntelliJ, right? Because we are writing a Java program, so we know okay, we need IntelliJ. This is a PyCharm. But PyCharm we need it when we will go the PySpark code. So whenever you are writing PySpark code, you will have to use this PyCharm. So you have to work on the PyCharm. So both the editor you keep it in PyCharm and the IntelliJ. So you download the IntelliJ community version and keep it in the software and go to the bin directory. Go to the bin directory and then you can do like you can start and go. So that's it. Everybody's VirtualBox and Hadoop installed and Hive installed. Hadoop installed, at least Hadoop. Without Hadoop, you cannot run any component. CSS, mapreduce, Hadoop. Hadoop first. When Hadoop is not running for the IntelliJ, it's fine because you have to run it as a program. So It's not Spanish. Wait, have any existing project, you can have the option open. You can open any project. And when you create a new project also, here is the option file open. You can create a new project. Same for the my Hadoop file system, Hadoop API, right? HDFS API. So all those code, everything is in one project. We can keep it separate project. I have already discussed about the Maven project, right? How to create a Maven project, a Java project. Okay, from the scratch I showed. Okay, so how to create a Maven Java project, and then you can add your classes, form dependency, jar, and then you can run your and the form.xml you can right click and reload the form, right? So sometimes dependency is not able to find, so you have to. Okay, so now I'm going to tell you this map site join. Okay, so map site join, we have two classes. One is a driver class and one is a mapper class. So there is no need of reducer class because mapper class is doing the join itself. That is the reason it is called the map. So here, so what we are doing here in the driver map site join distributed cache. Actually, distributed cache is a concept in
तेरे को दवाई दे रहा हूँ दवाई दे रहा हूँ
distributed cache is a concept in the MapReduce for sharing the data in memory. Right? Suppose your data is a very small and which can fit into the memory. Right? So we can use the distributed cache concept. So distributed cache, like you have some file. Suppose I'm telling the example of department and employee, right? The department file will be very small, right? How many department can be there in a file? Hardly 10, 15, 20, maybe max to max 100 department, right? I'm telling very big organization that if the very small company, right? So they don't have the more than 10 departments, right? So if I say department is a very small file, but EMP file can be very large. It could be a 100,000 employees or maybe more than that or more than that. So that could be a big file. Okay, so in this scenario, department.txt file, we can use a distributed cache. So here, how to add the file in the distributed cache? So in the driver file, if you see in the driver file, this is a driver. Already you've seen the driver code, right? We create a job object and we set the job.set mapper class, right? So all these things we are setting it. So if you see here the code, so first thing is for the distributed cache, we have to set add cache file. And this add cache file we are telling here, this particular file, department.txt file, okay, this particular department.txt file is my small file and I want to keep it in the cache. After that, I'm telling about my driver class as a jar by class. Okay. And if there is no reducer, I'm setting it here some number of reduce class 0. Why I'm setting the 0? Because I know there is no reducer is there, right? So I'm setting it to 0. There is no reducer, so there will be no output file will be generated. No reducer file will be generated. Output file will be generated, but it is a mapper output file. Okay. And one more thing I'm going to do here, I'm setting the output path of my mapper output file, and same thing job wait for completion I'm going to do. And right, previously I written driver code itself here itself in the main function. But now this time what I'm doing, here I'm calling one like this driver class constructor itself, right? I'm calling here, and I'm calling the here in the run function. So run, I created a function, and this function I have created a this code. So basically I'm using this extend tool, right? This extend tool is providing the one run function, and I have to override the run. So whatever code I write in my run function, that will be executed by this driver class. Okay. So once this all things are set, right, I'm setting the file input path and output format path. So these are all common things like we have to do for the driver. The only thing is the which is very different here, that is here the distributed cache to add cache file. So if I don't do this, so I have to load the file manually, like as a second input file. Okay, but here instead of adding manually the file, I want to keep it in the cache permanently. Okay, so whenever my file is changed, I will change the file in this location. I will change the file. Okay, so my file is location is fixed, right? Okay, I know department.txt file. The department will not change every day, right? Okay. That is the reason I'm using this department.txt file as a cache file. So next class is the map side join mapper class. So in this mapper class, if you see the logic here, there is a one setup function is there actually. So setup function is basically initially what the setup function will do in the mapper class, it will be reading all the cache files, and it will find out which cache file you have a department.txt, right? Because there are many cache files are there, like you have a department.txt or credit card payment.txt, anything which is a small file you kept it in the cache. But how will you identify which cache file you have to read? So you are telling here, you are matching here with your name is the file is a department.txt equal. So wherever this file is matching, you are calling a function load department hash map. What you are doing in this function? This is a completely Java code. You are reading line by line data, and you are reading the file, and there is the department ID and department name, department ID, department name, comma separate. So you are splitting each line and getting the two values. One is a key and one is a value. So key is your department ID and value is the department array of one. That is your department value, name, department name. And you are doing trim. You know already trim. What is the purpose of trim? Trim is basically leading and trailing space you are removing, because sometimes if your space is there in the key, so when you are matching the key, you will not get the correct value of the key, right? Okay. So what you are doing finally here, you are returning this hash map, because this hash map will be, actually you are not returning, you are using this hash map in your mapper function. So if you go to your mapper function, here, map function. So in the map function, what you are calling, you are first, what you are doing first here in your department map, so this department map is a global variable. If you click here, the department map is a global variable. The global variable is in Java, like the variable can be used across the functions. If on the top you define this function, this variable, this department map is a hash map type. So you can put the value in the map, this department map, and you can get the value. So you can pass the key, and key is your fixed parameter. So actually, when you are splitting the data of your employee txt file, okay, so employee.txt file has employee ID, employee name, employee city, employee. So last column is your department ID. So you are taking the department ID and get the department name. And finally, what you are doing, you are preparing a one output text line. And what you are doing, all the column values, right? 1, 2, 3, 4, 5, 6, and finally you are preparing the department name. And department name you are showing in the last and the tab separate. And finally, this value you are writing in the context. We already know about the context, right? We are having a key and we are writing the value as a complete string. This complete string is your tab separated field. And this tab separated field you are writing in the as a value. Okay. So now let's see that how the output look like. Okay? So I will create a jar of this project. So I have not shown to you on the Hadoop file system, right? How to submit a job for the mapreduce. So we will run this job as a mapreduce job on the cluster. Okay. So we go to the edit configuration and I will create a jar of this. So I will take a Maven type. So Maven type project I will go and in the Maven type simply I will do the clean install and I will do the clean install command and then I will do this mapreduce jar. I will. So where this jar will come? The jar will come in the target. A new jar will come. Okay, the jar is created. I copy this jar. Copying the jar. I will start the terminal here. So now I need a Hadoop, right? Because I'm running the code on the Hadoop file system. So I have to start the Hadoop synthesis. So what is the path of this? So some sample file is already there. I show you that file. Same file we have to keep it on the Hadoop file system. Okay, in the driver class, you can see what is my distributed cache location. Okay, so I can find the data over there. site join. You can check this one. I think I created a last one. Let's check. So, mm, mm. So if you see here, my distributed cache location is there, TC. Okay, if I go to, if I do access ls, distributed cache location, TC, I have my distributed cache file department.v. So now you can see here, I do fs minus cat, and this is my, I have created a file, I copied a file in my distributed cache. So this is my distributed cache location. Okay, so you can see here, how the data looks like, of the department. The department.txt data is like this. This is the old one that we are using comma separate because we are splitting the data comma separate. So I kept it. Here also DC folder. Here also department.txt. Mapper that separated or comma. So, Okay, we got the location. Let's see this file. So this is the employee.tsp. Even we can go with the space, but tab space is not fixed space, right? Like sometimes it's we see this is the data. So this is the comma delimited data is there. Okay, so we will use this data. Okay, and same like for distributed cache file like department.txt. So if you see the department.txt, that is also comma delimited data. So we will use these two files. Yeah, this part. I will create a completely new folder, okay, in the Hadoop file system. So Hadoop fs minus mkdir. I'm creating a one directory running test. Okay. In this directory, I will keep it one is a distributed cache, right? So I will create another directory /dc. So I will find out my distributed cache file is there in the. Okay, one more thing is if you are changing the location, right, in a code, also change the location because my code is using the distributed cache location. So then code will need to be, otherwise code will not able to find the distributed cache location. Even though I'm going to change here, but it will not be able to. So Hadoop fs minus code, I will be putting this department of txt. I will be putting next right joining test class is. I copied this one and I should copy another file. Put employee location. I will go back to my employee ESP file and I will put it directly in the map site context. So if I see my structure is one file is in the map site join test and other file is in the DC. So this path I need to change in the core and create a jar again because this jar which I'm going to use, this jar will be not worked out. So I have to use another jar. So if I find the location of this location, right? So even I can so this is my project location. So this is my project location. Here I can start terminal and if I want to modify the file, I can usually do as well as these are all driver classes. So my driver classes, they have a map site join. So I go to in this class, I change the location, so map reduce, map site join test, and site join test. Okay, and rest other things are fine. I copy this. Just save this one and do here npm install. Sometimes editor is being problem. You can directly use diagonal command. So you will be done. And here in the CD part, you get here folder. So you get a jar here. So we can run the command anywhere. This Hadoop jar command we can run anywhere. So Hadoop jar name. Okay, next thing is the class with the package. So this is my driver class. So package is org example, and driver class is this. I will give here org class name. And after that, I have to give my input file path. So that's why join test. So TSL. Okay. Distributed cache file name you don't need to do, because distributed cache file it will be taken by the code itself. And next is a map site join test and some output directory. So map site join test. I will create a one OP output folder. So this folder should be new folder. Okay, where I will my output data will come. So I'm running my mapreduce job, and this job is running on the cluster. On my Hadoop node is running. So you will see here one application ID is created. For every job, one application ID is created. And this application ID is used to track your application. Okay, suppose this application ID is application 0001, and this application ID you can copy. So you should know how to check the log in the resource manager. So resource manager is your cluster, right? Resource manager, where you can check the log of your code. So you can see a job is completed successfully, and this is a mapreduce job, and this is completed. Map is 0% and 100% is a map. There is no reducer because I made a reducer 0. When I made a reducer 0, so I'm not able to see any reducer. Okay. So now I want to check the same log on the cluster, so I can use localhost with 0. Create this cluster. So in this cluster, you will be able to see your application ID 001. You can, this is a type of job is mapreduce, and you can have the log. So anybody asks you, right, how many ways we can check the log? We can check the log using the console, like using the job resource manager URL, right? You can check the log. And we can check the log is the yarn log command also. So if I go, right, if I check the output, our main purpose to check the output, right, we have to see Hadoop access in the website join test slash OP. So if I go to this OP folder, I will check only one mapper file output is coming. So only one file, that is a mapper output, because it's a part M000. And if I see the content of this file, so I will find it has concatenated data of employee. But finally data I have put it as a tab separate, not the comma separate. If I want to comma separate it, I can make it in the code, comma. So I will get it, the data will be coming to the top. But now I kept it data is a tab separate. So that is the reason data is coming a tab separate. So this is clear. This is the map site join. And quickly I show you the reduce site join also. So reduce site join. these contours. Okay, so second example, we are looking at the reduced size joint. So let's see that what is the reduced size joint input. Okay, so in the reduced size joint, our input for reduced size joint, we have the two mapper, right? Okay, one mapper is a order mapper and one is a customer mapper, right? So in the data, I have one is a transaction detail, one is the customer detail. I show you both the files, okay, how these two files look like, and these two are two mappers. So one mapper you have a like customer ID you have 001, 002, 003, and you have order ID you have. One order ID is 4001, 4001 two times, 4002 is three times or one time, and 4003 is one time. But if you see the okay, this is a transaction detail and customer detail you have. Here is a customer ID. So this customer ID is mapped to your transaction detail. Okay. So either way you can do join. Okay. If you have multiple customer ID, okay, so you can write a customer ID here as your key, like your join key, right? So 4001 is two time is there. 4002 is a one time and 40003 is a one time. So this order, right? If I say the two time order for the 4001 and one time order for the 89 is the 40002 and 98900 is one. But if you see here, 4004 is not having any order. So it means I will get the count of number of count of order is 0 and total cost is 0. Okay. So this is my two input data set. Okay. I will upload this data set to the Hadoop file system and then I will use the reduced size. So I will show you the code. So in the reduced size join, in this one, I have written only one single class. Yesterday I told you we are writing the single class, right? Static inner classes are there, like two different mappers, two different classes, okay? One reducer class. So these are all different classes are there in a one single class. And so I have created a one single class is reduced size join. And this reduced size join is a one single class which is having a driver and other mappers and reducer. So all the four things are in one. So when I do size join, when you see this is the driver part, okay, of the reduced size join, and here I'm using multi-input type. What multi-input type is there? Multi-input type taking two different mappers together, because generally we have one input format, right? So we have one input format, so we have only one mapper. But here the scenario is you have a one customer mapper and one transaction mapper. So you are reading two files parallelly. So I will tell you, right, like this map side join is used in the example where your one data set is very large and one data set is very, very small, like department affiliates. And we use the distributed cache to load the small data set. But when you are using two large data sets, if I say customer data set is equivalent to the transaction data set, right? So customer can be little less, but transaction mapper can little bigger, right? Because one customer can have multiple times. So I will say almost it will be equal size, right? I will not say like very, very less or very, very more, right? It's like near about same, because customer and mapper like transactions, like ideally both are large. So this is the driver class. And if we look at the mapper class, so first is the customer mapper class. So we have the data is splitted by comma. And what I'm writing in the context, I'm writing as part of 0 and I'm adding the suffix, prefix, not suffix, prefix. So whatever is a customer data is there, I will add a customer like CUST. Because why I'm doing this? Because I want to identify in the reducer whether my data is a customer or order, because I cannot identify clearly if data is a customer and order. Because of this, I can identify, because this prefix is telling me your data is a customer type or order type. And the part one, so there are two things are there, part of 0 and part of 1. When you look at the data of customer data, part of 0 is your customer ID and part of 1 is your customer name. So what you are doing here, part of 0 you are adding the customer ID as a key, and value you are adding name in the customer, because I want to print the customer names also. Like one particular customer has total cost of order, how many orders he has. So I want to add a customer name as well. Okay. So for that purpose, I'm adding the value. Same thing like I'm doing the transaction mapper. So here I'm splitting the part like complete string, and here I'm taking a transaction part too. So this is and this is the same thing. Here this is also customer key and this is also customer ID. Okay. So if I see part 2 and part 3 I'm taking. So if I go to my order like transaction, so part 2 is the 0, 1, 2. This is my part 2 and this is my part 3. So part 3 is the cost I need and part 2 I need is a customer ID, so that I can match this 40001 customer ID who is the customer name. Okay. So again I'm going to put the key and value, but here I'm adding a prefix, this transaction prefix. And what logic I'm writing in the reducer is little complex here, because reducer is basically combining the data, aggregating the data, right, for the same customer. So here I'm iterating all the data, because here all the data is coming, right, whether it's coming from the customer mapper or transaction mapper. So I'm splitting the here by space. So if I try to check here, if I'm trying to check here, if my part of 0 is a prefix is a transaction or customer, if it is a transaction prefix, so I will add my float, some value is there, the total count, total amount, and total amount I am getting to add total plus equal to total this value. Okay, whatever value is coming in the transaction. And I'm just calculating also total number of record also. Like for one particular customer, how many total number of transactions are there? So count plus plus also I'm doing. If it is a customer prefix, I'm taking the name part. You remember, right? I add the name part. I added name. I added the name, customer name here. So this name part, I'm going to take it, the name. And finally, what I'm going to do, I'm getting the total number of count, number of transaction, number, total amount, and I'm creating a one string, and that string I'm writing to the context. And final output, you look like this. Your customer name will be there, count will be there, and total amount will be there. Okay. So if I want to run this program, so I should upload the data, right? Okay. So this is the same, right? Because there is no change of the jar. So jar is the same. Okay, because I haven't changed any code in the. So the same jar we will use, but I have to put the data, right? So this data is here. I will open the terminal. I will create a one directory. Hadoop fs minus mkdir by join text, and I will copy Hadoop fs minus code. So both file I can keep it together. One is a customer details, and I will copy in the by join text. Okay. Second file is transaction detail. So I will copy transaction. Transaction detail. So I copied this file out. Now I go to the jar location where my jar is my local location. Okay, so jar is not another jar because I'm running my locally. Jar is my local location. So here same command Hadoop jar, your jar name, mapreduce jar, then your driver class. So now your driver class name will be this class reduce site join.java. So this class is my driver class. The driver class is itself is the main class, right? The main function in this class. So my org dot example dot my private. Now I have to provide two extra parameter, right? For two input parameter and one output parameter, because two input files are there, right? So one input file is right reduce site join test slash what is the file name? Exactly the file name should be the same. Plus underscore details. In one again, we have to give complete name. Reduce site join test underscore details. And then now I want to create a new output file. Reduce site join test slash. So I'm running my mapreduce. So here you will see the output will be coming, the reducer percentage will be coming here. Because last time you didn't get the reducer percentage, but here is reducer percentage coming, right? Because the reduce site join is happening here. So map is 0 initially, reducer is 0 initially, both are 0, 0. So this is the 0, 0. Now if you see 50% map, reduces 0, 100, 0, 100, right? So you can see here reducer came here, 0 to 100 came, right? But not 0, right? Reducer is coming, okay? So here, but because why the two mappers are there, 0 to 50, 50 to 100, because two mappers we are giving, right? So 0 to 50 processing happen 50 to 100%. Okay? And the reducer is initially till all 100% is not completed, your reducer will not start. Actually, here is a contract. Here is a contract in the mapreduce job, map and reduce function. When map is completed, then only reduce will start, because the output of the map is required to the reduce. So we cannot start the reducer before finishing the map. So that is a contract. So now we see the output. So here, what do access? So reduce side join by reduce side join test slash put. So in this slash my hyphen R file will come, because last time we got the file minus M because that was a mapper out. Now the reducer output is the minus M. So you can explain this kind of example, like how the joining is happening in the mapreduce. So Hadoop fs minus cat. Okay. So you can see here, this is the customer name is coming. How many transactions for the first customer? If you see the transaction, you will find the first customer has two transactions, right? 4001. So two are coming and 124. So 78 and 44, 45 will be 124. And second one is having only one, so 89.90 is coming. And if you see the test score is only one, 98.90 is coming. And the test 6 is no transaction, no total cost, so it's coming 0, 0. Okay, so this is kind of aggregation, right, at the reducer side. Okay, so this is all completed, the mapreduce. So tomorrow I will start Hive. So be ready for the Hive, right? Prepare the architecture of the Hive, prepare the internal, external table command in the Hive, partition, right? What is the partition, right? How to create partition. So I have already have in my description, Google, this group description, all the classroom links. You can check their Hive tutorials, Hive videos. You can prepare like before starting the tomorrow session, right? So there is a Hive architecture and Hive basic fundamentals like Hive internal table, external table. So you can go through all those concepts. Yeah. Okay. Thanks everyone. Thank you.
Thanks.